Hello students, welcome you all. In mass spectrometry, today I will explain the general fragmentation method, means a method by which any molecular ion may undergo fragmentation or any molecular ion may undergo cleavage. In my previous lecture, I told you about the different types of peak which can be seen in mass spectrum, like molecular ion peak, base peak, this isotopic peak, isotopic cluster peaks, and the metastable ion peak. So in this lecture, I will tell you how any molecular ion may undergo fragmentations, and there are different methods by which it may undergo fragmentation. For example, homolytic cleavage, which is called as the alpha cleavage. Then I will discuss about the heterolytic cleavage, which is called as the inductive cleavage. Then I will tell you the McLafferty rearrangement, means cleavage by McLafferty rearrangement. Inductive cleavage, which is also called as the beta cleavage. Then cleavage by ortho effect or ortho rearrangement. Cleavage by the removal of water molecule. And at the last I will also tell you the beta cleavage, that is inductive cleavage. So let us first discuss about the first main cleavage that most of the compound undergo, that is called as the homolytic cleavage, which is also called as the alpha cleavage. So first type is the homolytic cleavage. Or it is also called as the alpha cleavage. It is also called as the radical site initiated cleavage. So these are the different names of this homolytic cleavage: alpha cleavage or radical site initiated cleavage. Now this homolytic cleavage means between the same type of atom. So such type of cleavage is between the same type of atom or atom having the same or similar electronegativity. So it occurs between the atoms of same or similar electronegativity. For example, cleavage may take place between carbon-carbon bond or between carbon-hydrogen bond. We know that carbon and hydrogen, they have approximately similar or same this electronegativity. Then this is shown by, such type of cleavage is shown by half arrow, or which is called as a fish arrow. So it is shown by half arrow or we can say fish arrow. And in this type of cleavage, it involves the transfer of or it involves 3 electron process. This is a 3 electron. It involves the transfer of 3 electron. Okay, so it involves the transfer of 3 electrons. So you will see here that here overall 3 electrons are involved in the cleavage. And next thing, so in most of the compound you will see this type of cleavage. So it is seen in most of the compound. Most of the compound you may see this one. And then driving force. What is the driving force for this cleavage? Driving force is the presence of one of the unstable radicals. So radicals quite unstable. So presence of unstable radical is the driving force. So driving force is the presence of unstable radical. Okay, so this is some points for this alpha cleavage or homolytic cleavage. Now let us see one by one different example where this cleavage is possible. So as I told, most of the compound, it is seen in most of the compound. So let us see first. Suppose if we have any halide, alkyl halide, that here you will see the homolytic cleavage may takes place. So suppose you have alkyl halide, it is propyl chloride. So isopropyl chloride. So we have here, suppose first of all at 10 to 15 electron volt molecular ion, the ion that would be converted into the molecular ion, ionization takes place with the removal of 2 electron. So here, and electron that would be removed from this, that is most loosely held electron, that is this lone pair of electron that would be removed. So 1 electron will be removed from this lone pair. So 1 electron that will be removed from this lone pair, 2 lone pair remain as such. Now, so one of the point that I should mention here, that here it is 3 electron transfer process, and the next thing that it involves which bond will break. So alpha beta bond will break here. So it involves the cleavage of alpha beta bond. It involves the cleavage of alpha beta bond. Okay, alpha beta bond undergo cleavage. So suppose this is our molecular ion, this is molecular ion, and now at 70 electron volt we may know that it undergo fragmentation, and we are studying the general fragmentation method. So how it will undergo fragmentation? So as this is a radical cation, so this is quite unstable and it will undergo cleavage. How? It will cleavage of alpha beta bond. So cleavage of alpha. So this is our alpha bond and this is the beta bond, or this is alpha or this is beta. So alpha beta bond, it will undergo cleave. So this will undergo cleave. So 1 electron. So 1 electron over here. So these two electrons, they may form the double bond, and one of the CS3 methyl radical, here methyl radical will be removed. This methyl radical will remove, and you will get what you will get here, the double bond will come over here, and we have plus charge over here. Okay, so this you have got. So 1 electron over here, another electron here, that will form a double bond, and another for this cleavage, this is one of the this driving force for this formation of this cation, as that this is our resonance stabilized also. This is resonance stabilized. So you may see that, sorry, there is a, yes, this CH3, sorry, okay, so this is that. So positive charge will come over here, and so this is the driving force. So what you can see, if this is M, then one of the peak that will appear, this is the molecular ion peak, this is responsible for the molecular ion peak, and another peak that will appear, that is when this CH3 radical is removed from this molecular ion, then we will get another peak at 15 mass unit less than this molecular ion, that is M minus 15 peak will appear in the mass spectrum. Okay, so either in this case that this is the symmetrical type of molecule, either here this may the cleavage, this alpha beta bond may cleave, or this alpha beta bond may cleave. So this is now in the same way. Suppose I take another example, that is, suppose you have alcohol. Now first of all, this alcohol that would be converted into a molecular ion. This alcohol is converted into molecular ion, and at 70 electron volt. So this will undergo alpha beta bond cleavage. So this is alpha bond, this is our beta bond. This will undergo cleavage, this one and this one. So what you will get? You will get one of the radical, ethyl radical. So this ethyl radical is formed, and plus this you will get a radical over here, and this radical over here. This will form a double bond, and you will get a oxonium ion. So this is our oxonium ion. And the formation of this oxonium ion, the driving force for this is it is resonance stabilized. This can be written in a resonance stabilized form. So plus charge will come over here, and you will get a. So this is resonance stabilized. So one of the peak, that is, this is molecular ion peak, having this suppose some m by z value, and another peak that will appear after losing this ethyl radical, and ethyl radical, that is around 29. 29 is the molecular weight of this one. So 29 that could be subtracted from this m by z value, molecular ion peak value. So m minus 29 peak will also appear. So one of the peak that will appear at this due to this molecular ion, another peak will appear at 29 unit less than this molecular ion. So this is one of them. So here you have seen that this carbon-carbon bond, this alpha-beta bond, that is carbon-carbon bond, undergo cleavage. Now in the same way we can also represent one of the another cleavage. Suppose what I told you, this cleavage may take place between the atom of same electronegativity, similar electronegativity, either carbon-carbon or carbon-hydrogen. So this is the alpha-beta, this is alpha-beta, and this is also alpha-beta. This is alpha and this is beta. So it may also undergo cleavage. So suppose this is a molecular ion, this is a molecular ion, and it may undergo cleavage at 70 electron wave. This may undergo cleavage. So what you will get? So here one electron over here by fish arrow, another electron will here, means you are getting the one H radical or hydrogen atom, and plus double bond like this. Okay. So now this is resonance stabilized. This is again resonance stabilized, and you may write the resonance stabilized structure. So one of the peak. So one of the peak appear at this, that is molecular ion peak due to the molecular ion. Another peak is m-1 peak can also appear in this case. After the loss of this hydrogen atom, another peak that could be appear, that is the m-1 peak. And other peaks are also possible. So it may undergo other type of cleavage. But here I am only discussing the alpha cleavage. Here I am only discussing the alpha cleavage or homolytic cleavage. So these are the two. And in the same way, other molecules, suppose if we have ether, we have amine, we have acid, we have mostly in all type of molecule this alpha cleavage takes place. Now suppose third one, if I take the example of suppose ether. So this is our ether. Okay, so this is ether. And molecular ion. This is the molecular ion which is developed after the loss of one electron. Ionization of this molecule takes place, and suppose it has this is the molecular ion, and one peak will appear in a mass spectrum due to this molecular ion, and another peak at 70 electron volt. It will undergo fragmentation. This will undergo fragmentation. So how the fragmentation takes place? By alpha cleavage. So we are studying the alpha cleavage over here. So the cleavage may takes place either this bond, alpha beta bond, this is alpha beta, and this is also alpha beta. Okay, so this can occur. So suppose this is a symmetrical type of ether. Suppose I take the unsymmetrical ether. Suppose I take, let us take, this is the unsymmetrical ether. Now I have make it a unsymmetrical one. So this is now alpha beta. Now this is propyl isobutyl, propyl, isobutyl ether. So now what type of fragmentation is possible over here? So alpha beta bond will cleave. So the cleavage is possible either from here or from here. Two paths are there. Suppose if this is path A and this is suppose path B. One is path A, path B, and suppose I write it by path A, then what you will get? So this bond will cleave, this bond will cleave like this, and one another. So this bond will cleave like this. Okay. So we may write here. Okay. So and we have here one radical over here, and plus positive charge over here, and we will get a, what we will get? We will get a ethyl radical. So this is ethyl radical. So one of the cleavage, possible cleavage, this is the one of the possible cleavage. Now another possible cleavage, suppose by path B here. So it can again undergo cleavage, this one and this one. So this radical over here, another, this will form a double bond. So and we will get a ethyl radical. So we are getting the ethyl radical plus double bond over here and this one. So positive charge will remain as such. So this is the another one. So the mass analyzer will detect these cations. Mass analyzer will only detect the cation. Mass analyzer will not detect the radical. So we are getting the peak due to this molecular ion, and we will also get the peak due to this M minus peak at M minus 29. So this has the 20 mass mass unit of this is 29. Okay, ethyl radical. Again here also ethyl radical. So either cleavage may take place from here, or the cleavage may take place here also. So in both case we are getting the peak at M minus 29. This peak we will get. Okay, so now, so next example we may take the next number. This is ether one. Now suppose I take amine. Just take that. Now suppose I have this amine. Okay, so this is our amine, and suppose if we have a radical cation, this is the molecular ion, and it will at 70 electron volt, it will undergo cleavage. So this will undergo cleavage. So alpha beta bond. So this is our alpha beta bond, and this is a symmetrical type of amine. This is symmetrical type of amine. This is also alpha beta bond. So either from here or from here, this will undergo cleavage. So how? One of the electron, this bond will undergo cleavage. Carbon-carbon bond will undergo cleavage, and what you will get? We will get a positive charge over here, okay? And this one, and plus this ethyl radical is removed. So here you can see this iminium ion is formed over here. This is our iminium ion which is formed. And again here you will get the M minus 29 peak appear in this case. This is M peak, and another peak that may appear at M minus 29. Now suppose I take the example of aldehyde. We take the example of aldehyde. This is our aldehyde, and if the electron, first of all, the ionization takes place. How the ionization takes place? One of the lone pair of electron, that will be the most loosely held electron, will be removed first. So one of the most loosely held electron is removed first, and we are getting the molecular ion. And this molecular ion at 70 electron volt will undergo fragmentation. So how the fragmentation? Either what I told you, alpha beta bond will undergo cleavage. This is alpha and this is our beta, or this may be the beta, this may be the beta. So it will undergo cleavage, and suppose one of the electron over here and another electron here, and triple bond, positive charge, plus we are getting the propyl cation. So this is the formylium ion. So here if hydrogen is there, then this is formylium ion we are getting. Now, so this is one of the cleavage, or otherwise at 70 electron volt this hydrogen may also undergo cleavage like this. This is another possibility. So we are getting H radical or hydrogen atom and this one. So another type of this radical which we are getting over here, and this is resonance stabilized. This is again, this is resonance stabilized. This is also resonance stabilized. Driving force is, this is our driving force that you may write, and this is positive charge will come over here. Okay, so this is about the aldehyde. In the same way, suppose we have some aromatic compound. Let us see aromatic compound. And if we have a aromatic ketone, suppose this is aromatic ketone, and this aromatic ketone, this will undergo cleavage. So first of all we should have one of the radical cation. So this is the radical cation, this radical cation. Okay, this is radical cation. And now first of all homolytic cleavage, that is alpha cleavage at 70 electron volt, alpha cleavage will take place. So the cleavage, this is alpha and this is beta. So first cleavage will take place. This may be taken as beta, but initially the formation of this phenylium cation is which is not so much stable. So first cleavage which is possible is from here, the first cleavage that would be possible. So like this, and we will get a benzoylium CH3. So here again M minus 15 peak will appear in this case, and this is benzoylium cation. This is benzoylium cation. This is also resonance stabilized. Now in next step, what is possible? Removal of CO, carbon monoxide. Removal of carbon monoxide is possible. So this bond will undergo cleavage. So this is quite favorable. Removal of this gas quite favorable, and we will get a phenyl cation. We will get a phenyl cation. The removal of this. Okay. Now this has the 77, one of the characteristic peak for the aromatic compound. So here this is M by Z value is 77. Now this can again, it will undergo cleavage. So when we will study the different aromatic compound, then you will see that such type of cleavage in aromatic compound is quite favorable. So now it can again undergo cleavage with the removal of C2H2, that is acetylene. Again the removal of acetylene is quite favorable, one of the gas. So this will form a 4-membered ring with the removal of acetylene gas. So here this bond will undergo cleavage, and one of the bond will form between this carbon and this carbon, and next one, once the bond is formed between this carbon, this bond will again undergo cleavage like this. Okay, so what you have seen a 4-membered ring that is will form. The one of the 4-membered ring, and positive charge over here, and plus acetylene that we can see. Removal of this C2H2, removal of C2H2, and this has M by Z value 55. This is also a characteristic peak. If we are getting the peak at 77 or 55, it means our the molecule, the unknown compound possible is the aromatic compound is the possible. So this is about the aromatic ketones. Now suppose if you have this ketone, aliphatic ketone, again it will undergo cleavage. Suppose if you have this radical cation, this is a radical cation. So this radical cation at 70 electron volt, it will undergo cleavage. So alpha beta bond. So this is alpha, this is beta. This is also beta. So cleavage is possible from two sides. Cleavage is possible from two sides, either this path or this path. Suppose this is path A and this is path B. So from path A, what you will get? You will get from path A means this one and this one. And these two radicals, radical over here, they will combine to form a which is resonance stabilized, and plus you will get a ethyl radical. So M minus 29 peak will appear. This has mass unit of 29, so M minus 29. Or otherwise, so this is path A. From path B, what is possible? This bond will cleave here and like here. So CH3 radical plus positive charge, this one. This is possible. So here we will also get the M minus 15 peak. So either M minus 15 peak or this one. So now, if you will see, then this is removal of methyl radical, and here the removal of ethyl radical. So out of these two paths, which path is more favorable? So no doubt this path is more favorable because it has the removal of ethyl radical is more favorable and removal of methyl radical is less favorable. This is quite unstable. This is stable in comparison to this. So these two peaks is, so out of these two peaks, which is more intense peak will be, this peak will be more intense because here this path is more favorable. So this peak is more intense, this peak will be less intense. So we will discuss more about the intensity of peak when we will discuss the fragmentation of different compounds, different functional group. Now next is, suppose that is, let us take the example of acids, ester, amide. So suppose if I have acid, suppose better to take a general example. Suppose this is G, and here G may be OH, that is acid, G may be OR, it may be ester, G may be NH2, it may be amide. So if I take a radical cation, means first ionization will take place, ionization of this will take place, and at 70 electron volt this will undergo fragmentation. First ionization process, then fragmentation. So what you will get? You will get the cleavage will take place now. From this alpha beta bond will undergo cleavage, this bond will undergo cleavage, and like this. So we are getting one of this propyl radical. We are getting propyl radical plus a triple bond will form here, this triple bond, and a G. So G may be OH, OR or NH2, either acetate ion or this amide type of, or this ester type of. So like this is again, this is resonance stabilized. So formation of this is favored because it is resonance stabilized. This is our resonance stabilized. Okay, so here we can see that this has the mass number, propyl radical has the mass number 43. So 43 can be subtracted from this peak, that is the molecular ion peak. So M minus 43. So peak will appear at M minus 43. So one peak is due to this molecular ion, another peak is due to this fragmentation, that is alpha cleavage, that is M minus 43. So this is, as you can see, the alpha cleavage. In most of the compounds we have seen this alpha cleavage, which is possible. Now let us see the next cleavage, that is the heterolytic cleavage. heterolytic cleavage or inductive cleavage. Now, second type is the heterolytic cleavage, that is also called as the inductive cleavage. So, as the name suggests, so such type of cleavage occur between the atom of different electronegativity, which is just opposite of the homolytic cleavage. So it occurs between the atom of different electronegativity, atoms of different electronegativity. Okay, different electronegativity. Next thing that if you see this cleavage, then in alpha cleavage or homolytic cleavage, 3 electron transfer process it was. So it involves the transfer of 2 electrons. So it is 2 electron transfer process. 2 electrons transfer process. And another thing that is, it is shown by the complete arrow, that was shown by the half arrow. So it is shown by full arrow. Okay. So now suppose, let us take the example. So if you have the suppose you have alkyl bromide. So this alkyl bromide, first of all we have the molecular cation. So this is molecular cation, and this molecular cation is denoted by M plus, and this means that is a radical cation, molecular cation or radical cation. So how the inductive cleavage or this homolytic cleavage will take place? So due to inductive effect, it will pull this electron towards itself. It will pull this electron towards itself, and this bond will undergo breakage. So the cleavage will take place between the atom of different electronegativity, that is this carbon and this bromine. So this will undergo cleavage like this. It will undergo cleavage. So what you will get? We will get this cation, butyl cation, and one of the, you can see a bromine radical is formed over here. This is bromine radical which is formed. So one of the peak appear due to this radical cation peak or molecular ion peak. Another peak is this M minus, means due to the removal of this bromine. So bromine has the molecular mass of 79. So M minus 79, that will peak due to M minus 79 will also appear. Now peak due to M minus 81 can also appear. We know that bromine has the mass number 79, and it also exists in an isotope, that is 81. So I have already discussed the isotopic peak in my previous lecture. So bromine, if bromine is present, and if one bromine is present, then it will show 2 isotopic peaks. One peak at M peak, and another peak is the M plus 2 peak. So m plus 2 peak means m plus 2 peak, so that is 81. So here this will show 2 peak, that is this is m peak, and m plus 2 peak, that is means due to this bromine isotope. Okay, so here the fragment ion will may show the 2 peak, that is m minus 79 peak, or another peak this is possible is m minus 81. This is also possible, 2 types of peak. Okay, now in the same way, suppose if we have a isopropyl chloride and it's at 70 electron volt, this is at 70 electron volt. So suppose you have a radical cation, so heterolytic cleavage will take place between the atom of different electronegativity. It will undergo cleavage and we will get a stable isopropyl radical plus we will get a chlorine radical, fluoride radical. So this is showing the peak. This is the m peak, and this is the m minus 35 peak will appear over here, or this is m by z value for this is 43. This is takes place. In the same way, suppose if we have one of the ether may also okay. So this is our ether. Suppose this is ether, and here this ether. Okay. So suppose if this is our peak, that is this peak, and this peak that is molecular ion peak, and molecular ion peak it will undergo the heterolytic cleavage. So how the heterolytic cleavage is possible? Heterolytic cleavage means between the atom of different electronegativity. Either the cleavage may takes place from here. This is one of the possibility. What you will get? You will get this radical, and plus one of the peak will appear due to this peak. Okay. In the same way, the cleavage may takes place from here. So suppose this is path A path. This is path A, or from path B. Path B, that is like this. So you will okay. So here this that is m by z value, that is 29. So these two possibility. So it is shown usually this in alkyl halides, in ether, such type of heterolytic cleavage is possible. So this is about the 2 type of cleavage. Now in my next lecture I will discuss the McLafferty rearrangement as well as the McLafferty +1 rearrangement. Thank you.